In the name of Allah, hello students, welcome to our class today. I hope you are doing great as usual. As I said to you students yesterday, today we will start unit 3. This unit is very important students because we will have a discuss about the heart of the computer that call it processor or CPU in this unit. Also students, this unit is very interesting. I'm sure you will enjoy from this unit. As you know students, we will answer these questions in this unit. The first one, what's computer processor? Next, which are the part of processor? Next one, describe different types of processor. Next, which processor is better for your computer? The next one, what's cooling system in computer? Next one, which cooling system do you know? Next one, which companies are the common manufacturer of processor? And the last question of this unit is which company's processor are you using in your computer? Okay students, let's go ahead. Computer processor. Computer processor students is very important in the computer. Also we can say that computer processor is the heart of the computer. Because without processor, computer will not be able to do any task. Students, if we say that computer processor or processor in the computer is the heart in the human. Without heart, the human will not be able to continue their life. Also, computer without processor will not be able to do any task. Students, everything a computer can do for you, that is all of its magic, is controlled by its microprocessor. At the heart of every computer is a microprocessor, which is designed to perform all of the arithmetic, logic, and other basic computing steps that makes up the action of your PC. What you see as a word processor, a computer game, a wide web browser, your email, or any of the other software programs you perform on your computer or on your PC are in fact hundreds, even thousands of instructions that the microprocessor executes one at a time to carry out the action of each program. The processor, which is short for both microprocessor and a central processing unit, is a piece of electronic circuitry that use digital logic to perform the instruction of your software. Okay, students, the processor figure is shown in the screen, as you are seeing in the telephone screen or your computer screen. Okay, students, let's go ahead. Students, let's have an overview on the processor. Processors are invented by Marty Hoff in 28 October in 1937 in New York. Some of the processor manufacturer companies are Intel, AMD, Qualcomm, Motorola, Samsung, IBM, and etc. The processors are small size chips made by silicons that are placed inside the devices to perform the task or operating within second, and its speed is measured in terms of megahertz. The fetching, decoding, executing, and write back the instructions or the four main primary functions of the processor. In mobile phones, laptops, computers, washing machines, and etc. processor are used. Okay, students, let's go ahead. CPU speed. The best characteristic of CPU or microprocessor is its speed. The most common measure of a CPU is its speed. The speed is measured in cycle per second or hertz or Hz, where a cycle represents a single task performed by the CPU, such as adding two numbers. CPU speeds are usually measured in gigahertz or billion of cycles per second. Okay, students, let's go ahead. Okay, students, let's to have an introduction to digital logic. Before you get too deep into the digital circuits and logic of the processor, you must first understand some fundamentals that underlie the way the computer and the processor use electricity. It's perfectly normal for you to think of the computer as just another electrical appliance like a refrigerator or television, vibrating recliner, and so on. Sure, you plug it in, turn it on, and it works. What could be simpler? Oh, but there is a catch. It really isn't that simple. Okay, students, let's go ahead. The next one, to state logic. Like the light switch on the wall, the electricity in the computer is either on or off. Data is stored in the computer with electrical charts that are either on or off. In the early days of the computer, vacuum tube that we have had discussed about the vacuum tube computers in the computer fundamental books in the first semester, which were about the size and shape of a small light bulb, store data by turning individual tubes on or off. In today's computers, that same concepts is applied on a much smaller scale with the transistor, like the vacuum tube. The transistor holds an electrical charge that is, yes, you guessed it, on or off. Actually, the electrical charge in a transistor is on or two distinct electrical voltage levels. A higher voltage level represents one value, and a lower value voltage level represents another value. Because the computer has only these two electrical states in which to store data. The data has to be either very simple or some means must be used to allow multiple transistors to be grouped to represent more complex data. If all you ever need to store in the computer is on or off, true or false, yes or no. This or that young or young two state values that can be represented as two voltage levels, then the computer and the processor will work just fine without any additional complexity. Okay, students, let's go ahead. Okay, binary data. However, students, this section related to the system number or system numbers that we had discussed about them in the computer fundamental books. In this section, we just recall them. The term binary lossless means two number, and the two number associated with binary are 1 and 0. Simply by assignment, the two voltage levels in the computer can represent these two binary values with the lower voltage level equaling 0 and a higher voltage level equaling 1. Given this, then it shouldn't be too hard to understand that a transistor can store either the voltage representing 1 or 0 as shown in the figure and you're seeing in your computer screen or in the telephone screen. When a transistor is assigned a binary value this way, it becomes a binary digit or bit for short. Now you know that the computer can store numbers at the least two numbers anyway. Okay, students, let's go ahead. The next one, students, to store data larger than a single bit, a group of bits are combined. This grouping all have names. Some are very old names. I'm sure you will hear that. And each is capable of storing different maximum binary values. Here are some of the key digital elements uh, involved with the digital logic of the computer. The first one, students, bit. These students started from binary digits as a single binary number that can be either 1 or 0 as shown in the figure and you are seeing. The next one, students, is a binary word. Have you heard the students the binary word name yet now? Of course, yes, but if you didn't hear, now you heard. A binary word is one or more bits and usually range from 4 to 64 bits. The next one, student says the byte. The common 8 bit is equal to 1 byte or binary word. Depicted in figure as you are seeing in your computer screen or your mobile screen is probably the computer storage unit. You hear the most about it. The memory and the storage on the computer are normally expressed in bytes. A single byte can hold the binary value equal to 0 to 255 and decimal as you are seeing in that figure. Okay, students, the next one. Okay, enable, students. It's also important, the enable. What's enable, students? Have you heard the name of enable yet now? Enable, students, is a 4-bit binary word. It holds the binary equivalent of the decimal values 0 to 15. An 8-bit binary number is divided into two nibbles, so it can hold two hexadecimal number uh, we had to discuss about the decimal number in the computer fundamental book, and also we will have about hexadecimal system number in the next page. But in the next page we will have a recall name. A machine word is the number of bits that are required to hold the largest binary number a microprocessor can process. The machine word is commonly used to refer to the bit size of the processor. For example, computers are often described as having a 16 bits processor, a 32 bits processor, or a 64 bits processor. Okay, students, let's go ahead. Next one, student says storing data in a byte. The byte is used on the computer to store many types of data. The 8 bytes of the byte, or in commonly we can say the 8 bits of the byte can hold the decimal values 0 to 255. If it seems odd to you that 8 bits must be used to store from 1 to 3 digits, remember that only binary first and zeros can be stored in the bytes bits. How these values are stored in a bytes is by assigning each bit a different power of two values that as you are seeing in the table is showing the binary values assigned to each bit in the bytes. As you see, students, in the table, here is the bits the first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, and seventh bit, and 8 bits. Usually, students in a byte is a combination of 8 bits. The first bit, students, it has a value 2 power 0, and in decimal number, it has a value like 1. And students, the second byte, however, we write it in here, then by decimal number 1, 2, 3, 4, but all of them in the real, all of them are 1. But if they be 1, they has a value, but if they be 0, they will not be able to having a value. And the second bit, students, has a value 2 power 1, and that's equal to 2 in the decimal system number. Students, the third bit has a value 2 power 2, and that's equal to 4 in the decimal number. And the third one, students, the fourth one is has a value 2 power 3, and that's equal to 8 in the decimal number. And also the fifth, students, has a value to 2 power 4, and that's equal, or that it has a value in the decimal number like 16. The sixth one, students, has a value like 2 power 5, and that's equal to decimal number 32. The 7 bit, students, has a value like 2 power 6, and that's equal to 64 in the decimal number. The last one, students, or the 8th bit, has a value like 2 power 7, and that's equal to 128 in the decimal number. Understand that the first bit, as we explained it in the table, is the rightmost bit in the byte. If you add all of the decimal values for each bit in the table, the total is 255. The binary number, FB0, the 8 bits in a byte, represent 0 because none of the power of 2 values and used in the number. To put it another way, none of the power of 2 values was turned on. On the other hand, the binary values, FB, all of them 1, represents 255 because all of the power to 2 values are turned on, and therefore included in the number represented. If you wish to store a number larger than 255, you use more bits. This is where the machine would come in, and you can store the number 32,767 in the 16 bits. Okay, students, let's go ahead. Okay, students, it was our lesson today. This section was an introduction to the microprocessor or CPU, and because we had a large introduction to the CPU or the processor, because the processor is a very important component of the computer, and without the processor, computer will not be able to do any task, as we said, students. Okay, students, please pay attention to your homework. The first question of your homework is, what's processor? And the next question of your homework is, describe the processor speed. However, we had discussed about the processor speed, and also here's the question about the processor speed. Please do your homework, students, and share with me in the group or in the comments. Okay, students, the last question of your homework is, research about your computer processor. Okay, students, please research about your computer processor, which company's processor is in your computer. That's Intel or that's AMD. or how is the characteristic of your computer processor, and how many core does your processor has. And also, students, please give information about your computer processor speed. Okay, students, it was our lesson today. Tomorrow we will have discussed about the binary logic operations. Thanks for your watching. Have a good time. Good luck.